The Islamic Golden Age, one of the most important periods in the history of astronomy, mathematics, and science in general. Without it, modern science would never have come about, or at the very least, it would have come about much later and certainly not in Europe. Welcome to the 7th video in this series on the history of astronomy. If you're a returning viewer, it's good to see you again, and if this is your first time here, hopefully you'll find something you like. Let's start with a quick background on how the Islamic Golden Age came about. It all starts with the Arab conquest started by Muhammad, who essentially conquered or unified the Arabian Peninsula. Following his death, we have further expansions under the Rashidun Caliphate. These caliphs were essentially Muhammad's generals and close friends. Then control over the empire is taken over by the Umayyad family, and they further expand the empire to its greatest extent. At this time, this was the largest empire in history. The Umayyads then face a revolution and are overthrown by the Abbasid family, who take over almost all the empire, everything except for the far west, which remains under Umayyad control. The Islamic Golden Age starts under the Abbasid caliphs, as the result of them taking on viziers from prominent families from the culture that made up the city-states of the Silk Road, essentially the area that today is made up of the countries ending in Stan. If you'd like to know more about this culture and its scientific achievements, I covered them in the previous video in this series. The Islamic Golden Age is kicked off with what is called the Translation Movement. The Translation Movement starts under the second Caliph Al-Mansur, who, under the advice of these Central Asian viziers, starts printing paper and building libraries. The idea of the Translation Movement was to build libraries by translating as many texts as possible into Arabic. Al-Mansur also hires the first astronomers under Muslim rule. The 5th Caliph al-Rashid is known to have built himself a very large royal library. This is his personal library at this point. Al-Rashid, you may have heard of him. He is the basis for many of the caliphs in the stories of the famous 1001 Arabian Nights. The 7th Caliph al-Mamun builds the first observatories in the Muslim world. He also converts this large royal library into a public library, which comes to be known as the House of Wisdom, where he sponsors numerous scholars and polymaths, and they study and write about everything and anything they can think of. In this video, though, we'll be concentrating on their studies of astronomy and mathematics, which they mostly get from the Indians. There is a legend that Al-Mamun was so obsessed with academic pursuit that if somebody could bring him a book he didn't own, he would offer them the book's weight in gold for it. With the Islamic Golden Age now in progress, let's take a look at the timeline of Islamic astronomy. As I mentioned, the first two astronomers hired were Persian astronomers, Al-Fazari and Ibn Tariq. Ibn Tariq is known to have made the first astrolabe used in the Islamic world. He did not invent the astrolabe. Astrolabes had existed since the time of the Greeks, but he makes the first one in the Islamic Golden Age. At the same time, maybe a little later, overlapping with these guys, is another astronomer, Al-Marwazi. And these guys are primarily basing their astronomy off of Indian astronomy. And they're studying everything the Indian astronomers studied. They're measuring planetary sizes and distances, precession of the apogees, axial precession, and measuring the Earth's radius. Apogee is when an object in the sky is closest to the Earth, and precession of the apogee refers to a shift in when in its cycle a celestial object is at the apogee. Axial precession refers to the precession of the equinoxes, which I've already covered in previous video. This refers to the wobbling of the Earth's axis over a period of roughly 26,000 years. Al-Marwazi is also the first person to study the tangent and cotangent trigonometric functions. His word for tangent was the shadow, which I believe is still the Arabic word for tangent. A little bit later, but also overlapping with Al-Marwazi, comes a major figure in the history of astronomy and mathematics, Al-Khwarizmi. Al-Khwarizmi is doing everything these previous guys did, but he also introduces the Hindu decimal system to the Arabs, he invents algebra, and he's studying spherical trigonometry. He was made the head astronomer of Baghdad, and I already covered him in the previous video, so if you'd like to know more about his accomplishments, you can check out that video. If you're enjoying this video so far, please just take a quick second to like and subscribe. maybe share it with a few friends. And if you'd like to support the channel, I'll have a link at the end of the video, which can also be found in the description. Alright, getting back to the important stuff. Later we come to a guy named Al-Farghani, who was the first to translate Ptolemy's Almagest into Arabic. And immediately, he finds some errors in it and corrects them. The reason we even know about the Almagest is because it was heavily studied by the Arabs, or Muslims. I'll probably use the term Arabs and Muslims interchangeably here. In reality, this empire stretches from India to the Atlantic, so it encompasses all sorts of different people. Most of them are not ethnic Arabs, and many of them, particularly early on, are not actually Muslims. And some of them are probably just Muslim on paper for political reasons. But they're all living under Muslim rule and writing in Arabic, mainly, so for simplicity, I'll be using those terms interchangeably. Then we come to what some consider to be the greatest Muslim astronomer, al-Battani. Now, I'd like to point out that in the Islamic Golden Age, everyone is doing everything their predecessors did, plus their own new innovations. So for example, al-Battani is studying everything that his predecessor studied, and then adding his own innovations, and then the people that come after him will also study everything al-Battani studied, and come up with their own innovations. So we have a lot of repetition of measurements and experiments. One thing that is heavily studied by all of these Muslim astronomers is how to make the best astrolabes. In fact, there is so much astronomy being practiced that making astrolabes is a profession of its own. For example, we have this famous astrolabist, Miriam al-Astrolabia, which literally means Miriam the astrolabist. I believe her real name was not actually Miriam, that first name was attributed to her much later. She was known to make very precise astrolabes. Her astrolabes were valued by astronomers all over the Muslim world. And her father was an astrolabist and an astronomer, as was his father. So it was a family trade. Now back to al-Battani. Al-Battani, on top of being an astronomer and studying what all these other guys were studying, also is the first to introduce and study the secant and cosecant trigonometric functions. We now have modern trigonometry as we know it today. We tend to think we get our trigonometry from the Greeks, but actually we get our trigonometry from the Arabs, and the Arabs based their trigonometry on the Indian system. If you remember from your trig classes, we used the trigonometric system on the right here, which was the Indian system, with sine, cosine, and they had a third function called verse sine, which we don't use anymore. But those were the only functions they used. The Arabs then build their trigonometry and math in general off of the Indian system, and they introduce 4 new trigonometric functions and get rid of this verse sine, which is really just 1 minus cosine. On top of that, they introduced algebra, so we now have a fully geometric and algebraic system of 6 different trigonometric functions. That is the modern system we have today. Most of the trigonometric identities you know were developed and discovered during the Islamic Golden Age. By this time, the Arabs have taken over as the greatest astronomers in the world. That is to say, the most precise astronomers in the world. Prior to this, that was held by the Chinese, but they have now surpassed them. We now come to a guy named Al-Razi, or Razi. Now, he's not so much into astronomy, he's more into chemistry, or more precisely alchemy and medicine, but he is the first person we know of to have written about the scientific method. That is, that the only way to get the truth about nature is by careful, repeated measurements. Observation is the only thing that matters, and he's very rigorous about this. At one point, he was hired by the Caliph to build a hospital. Having noticed that diseases can be transmitted through the air, he set up an experiment where he hung meat in different parts of the city to see where it rotted the slowest, and decided that's where the air is the cleanest, so that's where we should build the hospital. We now come to a fellow named Al-Hujandi, who builds the first mural sextant in history. This allows for astronomical measurements with a precision of 1 arc second, 1/60th of 1/60th of a degree. I did come across a source that said Al-Marwazi wrote about mural sextant observatories, but didn't actually build one. So maybe they existed before Al-Hujandi, but his is the first one for which we have actual historical evidence, or maybe the idea already existed, and Al-Hujandi was the first one to actually build one. Making use of his now extremely precise observatory, Al-Hujandi notices that there is variation in the axial tilt of the Earth's axis. This is different from the precession of the equinoxes. The precession of the equinoxes refers to a wobbling of the Earth's axis as it points from one star to another, where this refers to a change in the angle of the Earth's axis. Now at this point you might be wondering, the Arabs come on the scene, they're not astronomers, and within 100 years or less, they become the best astronomers in the world. How does that happen? How do they go from desert nomads to the greatest astronomers in history in less than 100 years? Well, this goes back to this Silk Road city-state civilization whose members became viziers to the Abbasid caliphs. This civilization was a fully literate and scientifically advanced civilization. They had their own libraries, they had engineers, they had astronomers, and they had already adopted the Hindu numerical system. If you'd like to know more about them, they are the subject of my previous video on Science's Forgotten Civilization of Transoxiana. And the reason the Muslims rise so quickly to the top of the scientific world is that many of these Muslim polymaths, particularly early on, came from this civilization in Central Asia. We don't know about them because when they were initially conquered by the Umayyads burned all their books. So when the Abbasids take on these viziers from Transoxiana, the knowledge of this civilization flows into Baghdad and then flows out of Baghdad into the rest of the Islamic world. Back to the Islamic Golden Age, we now come to three of the most important Islamic polymaths, Al-Haytham, Al-Biruni, and Ibn Sina. These guys lived more or less at the same time, and actually Al-Biruni and Ibn Sina corresponded with one another frequently and apparently had very heated scientific disagreements with one another, very much like modern-day academia. All three of these guys explicitly wrote about the scientific method, and that this is the only way to find the truth. And all three of these guys studied just about everything. Al-Haytham is widely known for his work on optics, mathematics, astronomy, and physics. One thing he argues is that the heavens obey the same laws of physics as here on Earth. This might sound obvious to us today because everyone takes that for granted, but prior to him, people generally thought there was the world of human beings, and then there's the world of the heavens, the world of the gods, which generally is thought to have started around the moon. And the idea was the laws of physics apply to the world on Earth, the world of human beings, but then the heavens, they're not bound by any laws. It's the world of the gods, they do whatever they want. Al-Haytham argues this doesn't make any sense. Whatever the laws are on Earth, those are the laws everywhere in the universe. Al-Biruni is most famous for developing a new method for measuring the Earth's radius. If you'd like to know how this works, you can watch my video on Al-Biruni's method for measuring the radius of the Earth. Prior to him, everyone used Eratosthenes' method, or some variation of it. But now, we have a new method for measuring the radius of the Earth, based on completely different principles, and surprise, surprise, they both give the same answer. Al-Biruni also argues that motion is relative, and so it doesn't matter if you pick the Earth being at the center of the solar system, or the Sun, or some other object. Who's moving and who's at rest is just a matter of point of view. Correct. Motion is in fact relative. However, he does explicitly support the geocentric model of the solar system. These two may seem contradictory, but I suspect his reasoning here is, if motion is relative and we're on Earth, we might as well take the point of view of the Earth being at rest. That'll make everything easier. Sounds reasonable, but actually we'll find out much later that taking the Earth's point of view makes everything much more difficult. By the way, he's not the first Muslim to suggest that the Earth may be moving. That goes to a man named Al-Sizji, who argued that the motion of the sky is actually due to the motion of the Earth, and actually invents a new kind of astrolabe based on this principle. Ibn Sina is also more focused on alchemy and medicine, but one thing he comes up with is the concept of inertia. Prior to him, people generally took on Aristotle's point of view, which was that the natural state of things is to be at rest. That's why they slow down. Ibn Sina says, no, actually, everything will keep moving as it is unless you push on it. The only reason things slow down is because there's air resistance slowing them down. In absence of air resistance and any other forces, everything would have a constant motion, which also will turn out to be correct. Around this time, another astronomer named Ibn Bajjah, who is actually the first astronomer I've mentioned, who comes from modern-day Spain. So by now, the Islamic Golden Age has reached all the way to Spain, and the entire Islamic world, from India to the Atlantic, is dotted with astronomical observatories. Ibn Bajjah is the first to suggest that the Milky Way is actually just a bunch of stars tightly packed together. Now, he doesn't prove this. At this point, this is just a hypothesis, but he's the first person I know of to think of it. Now I'd like to take a moment to discuss the topic of optics, because optics is a very important subject in astronomy. And this field is essentially started by Al-Haytham, who is largely regarded as the father of modern optics. This is largely a result of his famous book Kitab al-Manzir, which just means Book of Optics in Arabic. This book spread all over the world, not just the Muslim world. It spread into India, into China, into Europe, and in it you'll find the basics that you will learn in any modern introductory course on optics. For example, it contained a law of refraction discovered by Ibn Sahl, which is today called Snell's law of refraction. Snell did not actually discover it. In fact, he wasn't even the first European to know about it. The first person to have discovered this law was Ibn Sahl, some 700 years or so before Snell was even born. But somehow, Snell got his name attached to it. A little bit later, the first correct explanation for rainbows was made by two different people independently in the same year, Alfarizi and Theodoric of Freiburg. And they both used Ibn Sahl's law, which they found in the Kitab al-Manzir, to realize that rainbows were caused by the refraction of light through water droplets. Alfarizi actually demonstrated this with an experiment in which he filled a giant glass globe with water and shone light through it, which he then focused into the pinhole of a camera obscura. Camera obscura being something he also found in the Kitab al-Manzir. The camera obscura is something you probably saw as a kid, where you get into a box with just one little pinhole, and lo and behold, you see the outside world projected through the pinhole onto the back wall of the box, but upside down. Now, the camera obscura was first discovered by the Chinese, and given that this Silk Road culture was in contact with the Chinese, that's where they got paper from, that's probably how it came to Al-Haytham. I don't think he discovered it independently. Al-Haytham was also interested in how vision worked. Prior to him, again, people generally went along with Aristotle's idea, who argued that your eyes send out light rays, they then reflect off of objects around you, come back to the eye, which then interprets the reflected light, essentially like echolocation or radar. Prior to Al-Haytham, Al-Kindi had already argued that this is not how it works. Objects actually emit light in all directions, and then our eyes just receive it. Al-Haytham proved that this was actually the case when he dissected some eyeballs and realized that they too have a pinhole, and light is just projected onto the back of the eyeball, very much like a camera obscura. He also develops the concept of a horopter. Horopters are the locus of points in which light will arrive in both eyes at the same angle, which is an important concept in binocular vision. Al-Haytham also discovers the law of reflection, that the angle of reflection is equal to the angle of incidence, also published in his Kitab al-Manzir. So this book contains the two most fundamental laws in optics, the law of refraction and the law of reflection. Based off of these two laws, he comes up with a general law for the trajectory of light, stating that light takes the easiest path. Now, I'm not sure what that means exactly, but this is very close to what's called Fermat's principle, which is that light takes the path of least time. Now, Fermat was fully aware of Al-Haytham and his book on optics, and while he is the first one to correctly state this law, it seems extremely likely that he got the idea or was inspired by Al-Haytham's principle that light takes the easiest path. At this point, we are at the height of the Golden Age, and we now start to see a little bit of a decline. Now, to be clear, this decline is very gradual, and it happens for numerous reasons. The Golden Age starts with the translation movement in the mid-700s, and the final nail in the coffin is with the fall of the Ottoman Empire at the beginning of the 20th century. So this is a very long period. In the meantime, during the second half of the Golden Age, While it's gradually declining, the knowledge of the Muslim Empire is spreading into Europe, and we have the rise of European astronomy, mathematics, and science, which itself is pretty much entirely based off of what the Muslims did. So in the next video, we'll take a look at the decline in the Islamic legacy on modern-day science. You'll be surprised to find out that the fingerprints of the Islamic Golden Age are all over modern-day science today. If you enjoyed this video and would like to continue this journey in the history of astronomy, please be sure to like and subscribe, maybe leave a comment, and click the bell to be notified for the release of future videos. And if you'd like to support the channel, you can go to my Ko-fi page, or you can just leave a super thanks. Thanks for watching, and I'll see you in the next one.